Good day, good people. My name is Sekwele. I am an online math tutor here to help young children turn their struggles into their successes. In today's video, we are going to be talking all about the math tricks that have gone viral on TikTok. This is actually part 2 of a recent video that I posted that is also on this topic. Now, in this particular video, we're only going to be looking at one math trick simply because there is a lot of information to cover. The math trick we will be looking at is from logical math. The link to this video will be down in the description box below. So as you could see, this math trick is all about adding mixed fractions. But now the question we should be asking ourselves is, what is a mixed fraction? Simply put, a mixed fraction is a whole number plus a fraction, which is a piece of a whole number. So simply put, that math trick really is you just adding two whole numbers together and adding two fractions together. But understanding the reasons behind each and every step in that math trick can be a bit complicated. So to simplify it, I'm going to use an illustration so you can actually see how adding mixed fractions works. I like to call it the pizza illustration. Let's say you have two groups of people. The first group of people ate 2 wholes and 1/4 of pizza, while the second group ate 1 whole and 1/3 of a pizza. Our goal is to see how much pizza they all had in total. In other words, we're gonna add these two amounts of pizza together. 2 1/4 plus 1 1/3. Now, logically speaking, your first step would be to add the whole pizzas together. So as you can see, in the first group, we have 2 whole pizzas, and in the second group, we have 1 whole pizza. You add all of those together, you have 3 whole pizzas in total. Now that you've added the whole pizzas together, we can now focus on the parts of the whole, the fractions of pizza. That means we need to add 1 slice of a pizza that was cut in thirds with another slice of pizza that was cut in quarters. Now this is a challenge. As you can see on the screen, the sizes of each slice are different because one pizza was cut in quarters and the other was cut in thirds. Therefore, the sizes of the slices are not the same. So it's hard to say, it's hard to articulate in words how much pizza this actually is. So we need to find a way to make both of these slices the same size. And we can do that by making sure that both of these pizzas were cut into the same number of slices. Think about it logically. If both of these pizzas were cut in quarters, then it's easy to simply say I have 2/4 of a pizza or 3/4 of a pizza. Or if both of these pizzas were cut in thirds, then you could easily say I have 2/3 of a pizza. But we can't do that because one is a third and another is a quarter. So how do you say in words how much pizza you actually have? The only way we can do this is if we make both denominators of these fractions the same. Once the denominators are the same, in other words, once both pizzas have been cut into the same number of slices, only then can we add them together. Now, to do this numerically, all you need to do is multiply one denominator with the other. And you need to do that with both fractions so that both denominators look the same. However, another crucial part of this step is that the number that you multiplied the denominator with is the number you need to multiply its numerator with. In a couple of minutes, you will see why this step is so important. Once you've done this, only then can you add these two fractions together. Now let's go back to the pizzas. Let's cut both pizzas into the same number of slices. As you can see on the screen, group 1's pizza has 1 slice out of 4 slices in total, while the second group's pizza has 1 slice out of 3 slices in total. If we were to make the number of slices equal, we would start by multiplying group 1's denominator by 3 and group 2's denominator by 4. But we would also multiply group's 1 numerator by 3 as well and group's 2 numerator by 4 as well. Keep in mind you have to multiply the numerators with the same number you multiplied their denominators with. This would make the first fraction 3 out of 12 and the second fraction 4 out of 12. This then actually means that if the first group's pizza was cut into 12 slices, then group 1 would have eaten 3 out of the 12 slices of pizza. That is equivalent to 1 out of 4 slices of pizza. They're the same amount of pizza, they're equivalent. We just change the number of slices, which would then change the number of slices that they ate, but not the amount of pizza that they ate. And also, the same applies for group 2. If group 2's pizza was also cut into 12 slices of pizza, that then means that group 2 actually ate 4 out of 12 slices of pizza, which is equivalent to 1 out of 3 slices of pizza. Again, it's the same amount of pizza that they ate. There's no difference in the amount that they ate. It's just that the number of slices are different because now we cut the pizza into a lot more slices. Therefore, they ate more slices. Just a quick side note, do you see why it was important to change both the denominator and the numerator? Because if we change the value of the denominator, and then kept the numerator as it was previously, then group 1's fraction would have been 1 out of 12, which would mean that if group 1's pizza was cut into 12 slices, then they only had 1 slice out of 12. This would have been incorrect because group 1 ate a quarter of pizza, not a 12th. These are two very different amounts of pizza. But by changing the numerator, we changed the fraction to 3 out of 12, which is correct because 3 out of 12 is a quarter of a pizza, which is the amount that group 1 had, obviously apart from the 2 wholes, because that is a quarter of a pizza that has 12 slices. So by making that change, by making it 3 out of 12, you didn't change the amount of pizza. Therefore, the amount of pizza that group 1 had stays the same. Same with the second fraction. If we kept the numerator the same as it was before, that would mean that if group 2's pizza was cut into 12 slices, they would have only had 1 out of 12 slices as well. Again, that would have been incorrect because, as we saw, group 2 had a third of a whole pizza, not a 12th. So we're not trying to change the amount of pizza they had, just the number of slices that they had. And by changing the fraction into 4 out of 12, we've kept the amount of pizza the same because 4 out of 12 slices is a third of a whole pizza. Therefore, the amount stays the same. This part of fractions is called equivalent fractions. This is when two fractions look different, but they actually have the same value. They are equal to one another. And if you struggle to understand equivalent fractions, please let me know in the comments and I'll be sure to make a video on that. Okay, so now that we've made that change, we've in essence made the pizza slices the same size. Only now can we add them. The basic rule is that you add the numerators, but you do not add the denominators. The denominators stay the same. Now, if you want an explanation on why that is the case, please be sure to let me know down in the comments and I'll make a video on that as well. But if you apply that basic rule, the fraction you will end up with when you add 3 over 12 with 4 over 12 is 7 over 12. Now the total amount of pizza that both groups ate, when you add both the whole number as well as the fraction together, becomes 3 whole pizzas and 7 out of 12 pizzas. Now I hope that illustration of pizzas helped, because now we're going to discuss the math trick itself and where each step of the math trick comes from. As you can see on your screen, one side has the longer method that you use to add mixed fractions, which is what we did with the pizzas, and on the other side it's the steps of the math trick. We're going to look at them simultaneously as we analyze the math trick. Now let's talk about where each step of this math trick comes from. Step 1 in this math trick was adding the whole numbers together. In our illustration, when we added the whole pizzas together, we added 2 whole pizzas plus 1 whole pizza, and that gave us a total of 3 whole pizzas. That is where the first step in that math trick comes from. Now the next steps in this math trick are how we add the 2 fractions together. Now that the whole numbers are out of the way, we're now going to focus on adding the fractions together. So let's discuss how these steps actually help us add these fractions together. As we mentioned in the illustration, we cannot add 2 fractions that do not have the same denominator. So we need to make the denominators the same. Now step 3 in the math trick is a method used to change the denominators and make them the same. In our illustration, we changed the denominators by multiplying each denominator with each other. Both denominators then became 12. However, in this math trick, all you need to do is multiply the denominators and make that the denominator to your final answer, which essentially is the exact same thing we did in the illustration, just much shorter. Much quicker. Now, as we've already discussed, when you make changes to the denominator, you need to make changes to the numerator as well to keep the value of the fraction the same as it was before you made any changes. We're not trying to change the value of the fractions, we just want to change how it looks so that we can add them. Now this is where step 2 in the math trick comes in. The step where you add 2 denominators and you make that the numerator of your final answer. So the question then becomes, why does adding the 2 denominators make the numerator of the final answer? To get the answer to that question, let's look back at the pizzas. In the pizza illustration, we multiplied the numerators with the same numbers we multiplied their denominators with. When we did that, the fractions became 3 out of 12 plus 4 out of 12. We then added the numerators, which gave us 7 out of 12. Now before we move on, did you notice that the new numerators look exactly like the previous denominators? Previous denominators are 3 and 4, and the new numerators are 3 and 4 as well. That's because we took the previous denominators and multiplied them by the previous numerators, which were both equal to 1. Now, as you probably already know, anytime you multiply 1 by a number, the answer will be that number. The answer to 5 multiplied by 1 is going to be 5, 7 multiplied by 1 is going to be 7, and so on. And that is why your numerators look exactly like your denominators. So in essence, the numerators turned into the denominators. They're old denominators. which can only happen if the old numerators were both equal to 1. Now this is a warning for you because this actually means step 2 in this math trick can only work if the old numerators of these fractions are both equal to 1. You can also see it in the video. Both of those numerators were equal to 1. If the numerators were equal to anything else, then step 2 cannot work. You cannot simply add the denominators and then make that the numerator of your final answer. Your answer would not be correct. However, if your old numerators were both equal to 1, then step 2 works fine. So just a warning, just be careful with that step. So that is where all the important steps of this math trick come from. Everything else is pretty straightforward and your final answer becomes 3 7/12. Now I'd like to mention again, this video is jam-packed with information, so if you struggle to understand it, it's fine. Just let me know down in the comments and I can make a video about fractions. Not about this math trick, but about fractions and explaining how fractions work. Because that's what actually makes this video seem so complicated. It's the fractions in the math trick. So if you want an in-depth study into fractions and how they work, please let me know and I'll be more than happy to release a video all about that. I do, however, have a video that touches on fractions, so I will link it up in the description. Be sure to check that out. And if you are in need of a math tutor, or if your child is in need of a math tutor, please be sure to go down to my website and schedule a free consultation with me. Thank you so much for your time and I will see you in the next video.